Suppose that we have the sequence 3, 7, 13, 21, 31, and we want to find a quadratic equation that would, or a function that would relate the term number to the term value. So, first of all, to establish that it is in fact a quadratic sequence, we look at the differences between terms, and we see that the difference between the differences is constant. That is the sign that it is quadratic. Once we get this number here, this number divided by 2, so the difference of differences divided by 2 is equal to the coefficient of the n squared term in our quadratic. So in other words, whatever our quadratic is that we're going to plug these values of n into, it has an n squared term with a coefficient of 1 because it's 2 divided by 2. So what we'll do first is we'll actually look at the difference between our sequence and a sequence that would consist just of n squared. So if we had just n squared, we'd have 1, 4, 9, 16, 25. And so we then subtract that from our sequence that we're working with, which gives us 2, 3, 4, 5, 6. So the fact that this is going up by 1 each time means that the coefficient of our n term is just going to be equal to 1. Because we can see that the difference between these are going up each time, which means that it's because of the inclusion of n in our quadratic. So, and the fact that these differences are 1 means that the coefficient of our n term is just going to be 1. So now we have n squared plus n. And so now if we look at what n squared plus n is, we get 2 and then 6, 12, 20, 30. And now when we subtract that from our sequence that we're interested in, we're going to get 1, 1, 1, 1, 1, which means that our constant term is just equal to 1. So in other words, n squared plus n plus 1 is the function that relates our term number to our term value. And so, for example, when we plug in 5, we get 5 squared plus 5 plus 1 equals 31, which is in fact the value of our 5th term in the sequence. If we want to know the value of the 10th term, we would just plug in and get 10 squared plus 10 plus 1 is equal to 111. Okay.